A personnel researcher has designed a questionnaire she believes will take an average of 35 minutes to complete. Suppose she randomly samples 20 employees and finds that their mean time to take the test is 29 minutes, with a standard deviation of 8 minutes. Determine if there is sufficient evidence to conclude that the completion time of the newly designed test differs from its intended duration. Conduct a test with the 0.05 level and assume the sample comes from a normally distributed population. Okay, so it appears that we're going to be doing a hypothesis test, and I kind of see that this idea of sufficient evidence to conclude, etc. Um, so we're going to need to figure out if this is a mean or proportion. And it looks like we've got quantitative data here. We're measuring time on each person in the sample. And it looks like she only has one sample. So as I set up my null and my alternative hypothesis, I will put one mean in each of the hypothesis statements. Now, they believe the mean time for completion is 35. That's what it was designed to be. And she wants to know if her sample is going to provide, sufficient evidence that the test differs from that. And when I see the word differs, they're not deciding greater or less. It's almost like they can't make up their mind. So we're going to do a not equals to 35. So there is our null and alternative for our hypothesis. It frames this out. Let's write down what we know. They used a sample of 20 employees, that's N, and the mean time to take the test was 29 minutes, and the standard deviation of this group is 8. And they want to use a significance level of 0.05. All right, I think we have enough to head over to Rguroo and to test this out. So here we are in Rguroo. We're going to go to the analytics pane, choose the drop-down menu, mean inference, since we're testing a mean, and one population. We don't have a data set for this one. We were given the information within the simple text or paragraph we got. And so the sample mean was 29. The sample standard deviation was 8 minutes. We were not given a population standard deviation. And the sample size was 20. Okay, so that's sort of the triplicate information we have: a sample mean, a sample standard deviation, and a sample size. Let's go down here. We have to give it a label. It's just for the output. I'm going to call this completion time. You can call it anything you want. We're going to click on the test of hypothesis. We'll enter in our significance level, which was 0.05. And our alternative, there's less than, there's greater than. And this is how Rguroo denotes not equals to. It's an exclamation followed by an equals to. So that means not equals to in the way Rguroo has used the keys on the keyboard. And then we're going to put 35. So Rguroo assumes that the null hypothesis is equal to 35, and then we've told it that the alternative hypothesis is not equal to 35. The last thing we need to do is to come in and determine what kind of method we're going to use here. And as I think about it, we were not given a population standard deviation. We have a small sample size, but fortunately we were given that last little blessing that said we can assume that our sample comes from a population that's normally distributed, which is just enough to have us use the t statistic. And that is, we're going to use the t statistic to test this out. Because we were not given a population standard deviation, we have to settle up here for the sample one, and that we know that we can rely on some normality. from the population. All right, I think we've got everything we need. And let's hit preview. All right, here we have it. Just repeats back to you what you told it. Down here's where the big information is. You can see it's using that hypothesis t-test for completion time, what we named it. And as we look at everything, sample mean, there's my t statistic at negative 3.3541. And our p-value at the end, I'm just going to turn it blue real quick with a highlight. It's really quite small at 0.0033. So let's go down and look at this. You can see here, in terms of minutes on the left, there's my 29 minutes way to the left. Many standard errors away. Matter of fact, it's 3.351 standard errors away. I know particularly how far away it is because of the t statistic tells us that. So that's just a sort of a generic t statistic here that's doing exactly in what we can see there with the units here, time. So we've got what we need to go back and make a decision. So just reviewing. Mean equals 35, not equals to 35. So here's our t statistic, t stat for short, and that is equal to negative 3.35. And our probability value, p value for short, was equal to 0.0033. So these two pieces of information right here were given to us from the software. Very useful for us. Now we're going to take this and we're going to put p-value at 0.0033 next to our significance level that was given. And we're going to need to make a decision here. Should we reject the null or fail to reject the null? Well, if I do a side-by-side comparison and put the proper inequality between these two quantities, we can see that the p-value is certainly less than our significance level. And what that tells me when that happens is that we should reject the null. Our data is significantly different. We had our 0.05 is kind of the level at which we decide if things are unusual. Here it's at 5%. Ours came in well below even 1%. So we're going to reject the null. So we will get rid of the null hypothesis and say that our data is supportive of the alternative, that the mean time to complete the test differs significantly from 35 minutes.